Moving on to infinite geometric series, we're going to start off with 1e, where we're given a value for a for t2, and we're trying to find the infinite sum. So what sum the series converges to when you just keep adding terms together. Now the first thing we need for this is our r value, so I'm going to go ahead and find that. Since I have t2 and t1, my r value will be equal to t2 over t1. 144 over 96, and we can reduce that to 3 over 2. Now, normally we would just go ahead and use our equation for infinite sum and go ahead and calculate that. However, my r value actually won't allow me to do so. Because I have an r value that is bigger than 1, the infinite sum of this is actually infinity. So just as a reminder, if we have an r value, it must be between -1 and +1 for the series to converge. Since it doesn't, our answer is infinity. Let's go ahead and look at the next one. This problem is going to come with a fun diagram. So we've got a ball, it's dropped from a height of 8 meters, so it's bouncing down to the ground and bouncing back up to about 80% of its previous height. And then it's going to go down again and bounce up again to 80% of its previous height, and it's going to keep doing that, and you kind of have to assume that it's going to take an infinite number of bounces until it eventually stops and comes to rest. So we are going to be finding an infinite sum, but notice a lot of these have kind of a double. The ball goes up and the ball comes down again. So we're reaching each of those distances twice. So if we're looking at total distance the ball travels, we need to double all of those. The only one that we do not double is the very original one, because the ball started from the top. So we can double our original value from 8 to 16 and then calculate everything once, but we'll have to subtract 8 to take away the fact that the ball actually started at the top and not at the bottom. We'll just start with an a value of 16 because that's a lot more convenient than trying to do two separate series and adding them together. So in that case, our r value is 80% of its height, or 0.8. Our infinite sum is going to be a over 1 minus r, so 16 over 1 minus 0.8, or 0.2, and that is equal to 80. However, our total distance, we're going to need to take away that 8 that didn't exist, the dashed blue line. So our total distance will be 80 minus 8, or 72. And meters. Okay, pretty straightforward calculation. You just kind of have to be able to set it up for the movement of the ball. Let's take a look at number 4 next. Again, this one's actually pretty straightforward, so we'll set up the equation and I will leave it to you to solve this one. We have a helium balloon. It's rising 70 meters in the first minute, so that's our a value, 70. And after that, each subsequent minute, it rises 12% less than the previous amount. So for example, instead of raising 100%, it's going to be 100 minus 12%, which will give us 88%. I'm going to write that as a decimal, 0.88. There's no up and down movement, so this is just a straight up infinite sum calculation. Our r value is between -1 and +1, so we can go ahead and do that. And we'll be calculating 70 over 1 minus 0.88. I'll leave it to you to find the actual value of that. And finally, let's take a look at number 5. Number 5 is a little different because we're actually trying to find the bounds on x. So what is the smallest or biggest value of x you could have, so that we have a geometric series with a finite sum. We want it to converge. Now we have for a an a value of 3, And we can see it's being multiplied by x plus 2 each time, so we have an r value of x plus 2. Now, we know our limits on r. It's got to be between -1 and +1. So let's just put the x plus 2 in there. X plus 2 has to be between -1 and +1. And we can rearrange this to have restrictions on x by just subtracting 2 from every term. So x needs to be between -3 and -1. All done.